All right, welcome to Miss Mason Explains the Scientific Method. You guys have been exposed to the scientific method really early in elementary school. So we're not going to spend too much time going over what is the scientific method. We're going to be focused on certain things that are important in psychology. All right, so the scientific method, it's simply a way that we can test our ideas about the world. It's a process. All right, and to dumb it down, you set up a situation to test your idea, your hypothesis. You make careful and organized observations. You analyze that data. And if the data doesn't fit your hypothesis, then you modify your idea and you test again. All right. So in psychology, we've actually used the scientific method to find a lot of interesting things. Here are some of them. One, the brain can recover from massive early childhood brain damage. Sleepwalkers are really not acting out their dreams. It is just a sleep disorder. All right. Our brain does not have accurate memories locked inside like video files. No, no, no. That's not actually what happens. All right. There's no hidden and unused 90% of our brain. Sorry, those of you who watched, what's the movie? With Scarlett Johansson. Anyways, no, you don't have a hidden 90%. We only use 10% of our brain. No, no, no. We've actually used the scientific method to find out, no, we use all of our brain. And we actually found out using the scientific method that people often change their opinions to fit their actions. And this actually refers to cognitive dissonance and the foot in the door phenomenon, which we are going to talk about both of those at the end of this course in our social psychology unit. All right, so we are going to talk about the scientific method today. All right, we're going to talk about the basics: theory, hypothesis, operational definitions, and replication. All right, we will be talking about these research types, these research goals in our next Miss Mason Explains lecture. All right, so let's start. The theory. All right, so theory. It is different from hypotheses, okay? Theories are not guesses. They are a result of carefully testing many related guesses, all right? They're a set of principles built on observations, all right, that explain some phenomenon and predict its future behavior. For example, this is the example I'm going to use for this unit. All ADHD symptoms are a reaction to eating sugar. That is a theory, okay? Now, flip it. What's a hypothesis? A hypothesis is when you make a guess about something, all right? A hypothesis is a testable prediction consistent with a theory, all right? Testable means that you can create a process to make observations to find out if your hypothesis is true. So, using our theory of all ADHD is about sugar theory, what could be a prediction? What could be a hypothesis of that? Think about it. Okay, one hypothesis could be if a kid gets sugar, the kid will act more distracted, impulsive, and hyper. All right. However, in order for us to test the all part of the theory, we're going to have to develop a hypothesis of ADHD symptoms will continue for some kids even after sugar is removed from the diet. Okay? All right. So, let's discuss some dangers when we're testing our hypothesis. So, some of our theories can bias our observations. Okay. When we're looking at our observations, we might only select the data that supports what we already believe. And there are some safeguards against this that we are going to discuss. First is design your hypothesis to disfirm your theory, okay? And the other one is observational definitions. Now, observational definitions are where you take the hypothesis and you have to break it down. You have to say exactly, what does this word mean? What does this mean? So, how can we measure ADHD symptoms? All right. Well, impulsivity. What does that mean? Well, it's the number of times the number of times per hour that a student calls out without raising their hand. That's how we are going to test impulsivity. All right. Hyperactivity. We're going to define this as the number of times per hour the student is out of their seat. So when I'm observing, that's how I'm going to find out if a student is hyperactive. They're going to get up out of their seat. Check off hyperactivity. And the last one is inattention. We're going to define that as the number of minutes continuously on task before becoming distracted. That's how we're going to define inattention. Okay? All right. Now, the next and the final step in the scientific method is replication. This is really important. You have to be able to replicate your experiment, okay? And what this means is that you can try the experiment, the experiment. You can replicate the survey. You can replicate the natural observation by using the same procedures and observational definitions, okay? So you can introduce a small change in the study, all right? Such as trying the ADHD sugar test on college students instead of elementary students, but you're still looking at impulsivity, hyperactivity, and inattention the same way. You're still going to observe them for impulsivity. How many times per hour do they call out without raising their hand? Okay, but now we're changing who are we actually watching? Are we watching college students or elementary students? Okay, all right. And just to review the scientific method, all right, so first you're going to boom. Okay. Gonna think of an interesting question. Why does that pattern occur? All right, so we make an observation. What do I see? Boom, boom, boom. Think of an interesting question. Boom, boom, boom. We formulate a hypothesis. What are the causes of this phenomenon that I'm wondering about? Then we develop testable predictions. My hypothesis is correct. Then I expect A, B, and C. We gather our data. All right, this is where you actually do the experiment. And then, boom, you're going to either refine, alter, expand, or reject your hypothesis. Okay, keep going, keep going. And then at the end, you're going to develop a general theory. All right. So like I said, you guys have been exposed to the scientific method many, many times. So I'm not going to go into deep into this. So we're going to use this as the one example for the research process in psychology. So first, we have a theory that low self-esteem feeds depression, all right? So this leads us to a hypothesis that people with low self-esteem will score higher on a depression scale. So then we are going to administer tests of self-esteem and depression, and we're going to see if a low score on one predicts a high score on the other. We're going to see if there is a correlation. All right, and then we go back up, and does this confirm, reject, or do we need to revise our theory? So you see, it can be a huge cycle in our testing a theory, okay? Our question, our idea of why does somebody do what they do? Why do they think? Okay? All right. This is the end of Miss Mason Explains the Scientific Method. Thank you for viewing.